Okay, so what we're looking at here is how to determine the equation to a polynomial from its graph. So we've got some quadratics or some parabolas, we've got some cubics, and we've got some quartics. So we're going to have a look at how this works and then some patterns and things like that we can find from them all. Just realised I had to have a point here, so we can call this, I don't know, -1 and 1. Okay, so what we're trying to do here is you'll be given enough information to work out whether you've got a parabola or a quartic, or whether you've got a cubic and a para 5 or whatever the case may be. So you have to be given that kind of information. But what we do is we look at the form and the information that we've got. So here we look at this thing here, this first one, and we are not given any intercepts. It doesn't have any intercepts, but we are given a turning point. So we're given a turning point, we're given a y-intercept. So what we need to do is we need to write it in what kind of form? Turning point form. So we write this as y equals a, we always have an a there, x minus, and we've got a 2, so that's 2, squared plus 1. Going to be interesting to see if we fit all this in. And then to solve for the a, what we do is we substitute our values of 0 and 2. So 2 equals a, 0 minus 2 squared plus 1, and then we use it to solve for a. And we can do that on CAS just by typing in this in the solve function. So that's what we've got going on there. We always put, so whatever point we're given, we might be given a y-intercept, we may be given some other random point, I don't know, but that's what we substitute as our x and our y coordinates. Over here, now, with this case, we are given 2 x-intercepts. Now, we also know x-intercepts are factors, so we write this one in factor form. So, y equals, and once again, we have an a, we always have an a, x plus 3 for this point, and we have x minus 1 for that point. And then from there, once again, we will just choose the x-intercept. So, sorry, the y-intercept, so at y equals -2, x equals 0, so we've got a, 3, -1, and then use that to solve for a. Once again, we just do it on CAS. Okay, next one along, cubics. Now, we've got this in our, it's equivalent to a turning point form, it's the point of inflection. So once again, we write this as y. I'm actually going to move that up a little bit. I'm going to write here, y equals a, we always have an a there, x minus 1, because we've got a 1 there, cubed, plus 3. And then once again, we've got another set of coordinates there. Okay, so we've got this point 1 and 1 here. That's our, -1 and 1. That's our other point, and we're going to use this to identify a. So what we'll do is we'll substitute that into the equation. So I'll say 1 for y equals a, and we've got -1 minus 1 cubed plus 3, and that'll let us solve. Once again, that'll let us solve for a. So we end up with like -11 or something. I don't know. 1 and 11. I don't know. It doesn't matter. So that's what happens here. So it's a little bit different when we've got this case here. Now we've got we've got a turning point there at the x-axis. So that's a repeated factor or a double factor. So this one we write as being, write it up here, y equals, and a, always an a, x, we've got -2, so it'll be plus 2, squared, and then if I could, I'd write next to it x minus 3, because we've got that 3 there. Make sure it's a minus, and then once again we'll be given another point, it may be a y-intercept, maybe something else, and we use that to solve for a by substituting the x and y values. Okay, cubic, a little bit different here, and what we do here, we've got 3 points. We've got 2, we've got a 1, sorry, a -2, a 1, and then a 3, and then we've got a y-intercept. So we'd say y equals, we've got an a, always have an a, so we still got that time, a, x plus 2, x minus 1, and x minus 3. And then we substitute the point 0 and 1, because that's our y-intercept right there, into this to solve for a. Alright, quartics. So with this quartics, if we follow this one here, we've got a little point of inflection there. So that is a triple factor or a cubic factor right there at -2. And we've got this linear factor here at 2, and then we've got a y-intercept there. So remember, we're going to write this in terms of a. So we're going to say y equals a. Remember, we always have an a. And we'll have this point, x plus 2 cubed times x minus 2. And then to solve for a, we substitute 0 and -2, so 0 into here, -2 into here, 0 into here, and then we use the solve for a. If we've got this kind of a setup, where we've got two factors here, they're both turning points there, so we would write this as being y equals a, always with an a, x plus 1 for this point, all squared, and we multiply that by x minus 3 all squared for that point. Once again, we use this 1 and 0, 0 and 1, 0 and 1 to solve for a. Okay, the last graph that I've got here, because you pretty much just keep following this pattern no matter what you've got, is if we've got 4 factors here, 1, 2, 3, 4, so this will be y equals a, always with an a, x plus 1, x minus 1 for the second point, x minus 2, and then x minus 4. And we haven't been given a point A here in this instance, or sorry, a point to use to solve for A in this instance, so you will be given one. So if we had the y-intercept, once again, just 0 and that value. If we were given this value up here, well then we, I don't know, so it might be -2 and 10, for example. So we put -2 and 10, -2, -2 and 10 in there, and then we use it to solve for A. The other thing you've got to watch out for with these is that you may be asked to rewrite this in AX in your standard form of ax squared plus bx plus c, or ax cubed plus bx squared plus cx plus d, or whatever the case may be. I don't know, but that's one of the things you've got to be able to do. So you've got to be able to go from one form to the other, and once again, you can just do that on CAS by just typing in your equation and just saying expand, and it'll expand it for you, because CAS is pretty handy like that. So polynomials, you look at the polynomial you've got, and then you identify the information you've got. If you've got turning point or point of inflection information, you use that form. If you've got factors, then you would write it in factor form. So we've got factors here, factor form, factors, or sorry, linear factors, we have that, so 3, or however many intercepts, we write that. If we've got something happening on an x-axis, like a point of inflection or a turning point, well then we need those equivalent forms. So here we've got a turning point, that's got to be a squared. Here we've got a point of inflection, that's got to be a cubed. The other thing you've got to remember is if it goes the other way, so for example, let's choose a different colour, I'll use yellow. If our graph did this, hang on, if our graph went and did that, we still leave the a there. We don't make it negative. We should have a negative a. We should know that we get a negative a, and say we set this to being 2. Well then, in the first case, we would have put this -2 into y, but now we're going to put this 2 into y, and we should get a negative value for a. So you're not actually making a negative, you're solving for a, and it should become negative based on that. And that's just depending on how the other graph. So likewise with this cubic, or this cubic, or this cubic, or this quartic. How am I going to do this? Or this quartic, or this quartic. Okay, same deal for all of them. Follow the same steps, doesn't matter what you've got, and then you solve for A, and then you put it in whatever form you're required to.